everyone. Thanks for coming. My name is Moshe Shadmon, and I'm the founder and CEO of AnyLog. AnyLog is the company behind EdgeLake. EdgeLake is a new project under LF-Edge, and it's about managing data at the edge. And I would start by saying that companies today move their data to the cloud, not because the cloud is such a great solution for edge data, but because they don't really have a choice. The edge is a very, very complicated environment. I'll touch some of the problems there. So just at high level, what is EdgeLake? By the way, AnyLog is the commercial version, but everything that I'll be talking to you about today, you could do it with EdgeLake, the open source platform. So the first, it's a completely decentralized platform. It manages the data without the need to centralize it, without the cloud. I'll actually show you today a live demo of one of our customers that is using EdgeLake, which is a city in Kansas, in Sabetha, a really interesting usage of EdgeLake. And what EdgeLake does, it enables real-time insights directly from the edge. So rather than centralizing the data and getting the insight from some centralized location, with EdgeLake, you get the insight from the edge. And we'll go through how that works. The key thing is data remains in place. And there is a huge cost saving with that and huge simplicity. And it's all plug and play. So our deployments are hours or days. We're not talking about weeks of work. It's plug and play solution. So let's talk first about how data is managed today. So this diagram shows how companies manage their data, edge data today, and there is no way around it. Data is being generated in from some sensors or PLCs or cameras, and then the data is captured at some edge nodes. By the way, sometimes you need to plug some software at those edge nodes. Let's take an example. If temperature is above some threshold, you want to turn off the switch. But it's always local data. It's always done using proprietary software. The core of the data has to travel from the edge to the cloud. So from those edge nodes that capture the data from the sensors, the data goes into the cloud. And by the way, that's not a simple journey, but only when it is in the cloud, it's hosted in databases, only then the data is available to the applications. This is for sure, it's not a real-time setup. It's very complicated to do it when you have a lot of data and a lot of edge nodes, and we're all aware of the huge costs associated with it. So we listed here some of the problems at the different points where the data is being passed through. So with edge nodes, in most cases, it's proprietary systems, legacy systems that rules there. The massive transfer, if you have a lot of data where now it's doing a project with oil and gas rigs, tons of data, huge costs there. We all understand the cost of hosting data, large amounts of data in centralized databases. And then when it reaches the application, it's not real time anymore. So this is what we do. This is what EdgeLake does. So the starting point is exactly the same. Same sensors generate the data. The data goes from the edge to nodes that are hosted there. Those nodes could be switches. EdgeLake could be deployed on a small switch all the way to a large server. The data is captured there and remains there. But there is another thing that happens, and it happens in a completely automated way. So the software, what it does, it creates a virtual layer that spans across the entire edge. That now, if you've got an application, like the one that we're showing at the top, could be a dashboard, could be a process, could be an AI process, when they look at the edge, they don't see islands of data. They see a unified collection of data. They basically see a database with list of tables. You could select a table. You'll see the list of columns. You could select the column. You could issue a SQL query. You'll get the result back from the edge. So if we go this path, then there is a lot of value in this type of setup. So first, on those edges, it's not proprietary software. It's not legacy system. You deploy EdgeLake there. It's all plug and play. You maintain data ownership. The data remains in place. This virtual layer is created without any engineering effort. It is just created there. It minimizes the transfer of data to the cloud, and it's able to service the data to the applications in very low latency, next to real time. And we still show the cloud here. And the reason is the cloud is always be there, right? And there are always reasons why we want to transfer data to the cloud, but much less data. You would transfer to the cloud only things that you have to host at the cloud. For example, if you've got a Oracle database that needs the data locally and it runs on the cloud, move the data. But the core of the queries that had to go and be executed at the cloud could now be executed at this virtual layer. And it delivers the value to the applications. From the application point of view, there is no difference. They still see the same database and the same setup that they're familiar with. So just to summarize those points, data stays local. When you deploy EdgeLake, the data remains in place. It doesn't move. It creates a unified virtual layer that spans across your entire edge, where you could see the data as if it is centralized in a centralized database. It's all plug and play. You don't need to send engineers. I'll show you in a minute. I'll show you an example where it was deployed in a city, and it was a few days of deployment. It's open APIs, open architecture, and it scales. And I'll talk about scalability, why it scales, and why you could manage as much data that you have using this approach, obviously lowering the dependency in the cloud, and it's also very, very secure. So we'll talk also about that. So from here, all right, so I switched to a live demo. The green dots that you see are AnyLog nodes that are deployed all over the world. If you see a node somewhere, it is really deployed there. By the way, just to make it clear, we give the software users or projects that leverage us deploy it themselves. This is our test network, which I'll show you a few things on the test network. But our test network, those nodes are all over the world, and the nodes gets data from sensors and PLCs and cameras, whatever the use case is, the data remains there. And that's the only thing that needs to be done. From here on, the data is available. You could interact with the data. And to demonstrate that, I'll switch to a use case of a city. The city is called Sabetha. It's a city in Kansas. And Sabetha has a lot of infrastructure. They have a water plant. They have a wastewater plant. They have generators that generate the electricity for the city. And all those things, all this infrastructure generates a lot of data. And traditionally, their setup was such that data was captured from those PLCs to some edge nodes. And from there, like we've seen before, the data had to travel all the way to the cloud. They were working on those projects to bring the data to the cloud and host it there for almost two years, a lot of costs and a lot of expenses. The system integrator there deployed us on the nodes that capture the data from the PLCs in the city. So now imagine the city and a lot of nodes distributed in the city that are hosting EdgeLake instances. And then from there, he connected the dashboards, and the city was kind enough such that we could share the dashboard. So you're seeing here, for example, the electricity usage in the city. This is Grafana, by the way. So it's very open. You could connect to Power BI, Grafana, whatever platform you have, or any application, the interfaces. I'll talk a little bit about the interfaces later. So they could switch and see a generator. They could see aggregations of generators of data, all coming from this virtual layer. In the same way, they manage their wastewater plant. You could see it here. And I brought also the water plant, similar story. So everything that you see here is coming from the edge, from this virtual layer. 2 weeks after this went to production, the city asked the system integrator to terminate all their cloud contracts. So the city of Sabetha now is managing all their infrastructure directly from the edge. So I'll drill a little bit down and try to show you a little bit of what's going under the hoods. So I'll use this application. By the way, this app is like Postman. Everything that I do here, you could do with Postman. You could download it from our GitHub. It's just more consistent with EdgeLake. You could configure the buttons here to frequently use queries and commands, so you don't have to type them. But it's basically what it does. It sends REST requests. So here is a node in the network. This node is from here, one of those nodes. It's completely decentralized. So I'm picking a node which serves as a gateway to the network. So I'm just using the node as the point where my application, this browser in this case, or this application that runs on the browser, that it would be able to enter into the network. And the next thing that I'll do, I'll type a query, but because I've prepared it before, so I've got a SQL query here. All those buttons are a different example. And when I hit send, very much like in Postman, the query would go out to this node that is listed here. So let me do it. I'll hit send, and the query goes out, and the data comes back as if I'm working against a centralized database. But there is no centralized database. What we've got here are nodes that are deployed all over the world. And if I'll go back to here and scroll all the way to the bottom, you could see that the data came back from 10 nodes. So what happened here? I issued the query to a single node in the network, which is the node that is listed at the top, which was randomly selected. I obviously, let's say that this query is telling me the electricity usage in San Francisco in the last 2 hours. I don't know where the data is. I could have thousands of nodes in my network. So I pick one node. I don't know if it has data or not. And I just hand the query to this node. And from here, all the process is transparent. But basically, what happens under the hoods, this node looks at the query, so it knows what the application needs. And then on the other hand, it has a shared metadata layer, which we don't show it here, but I'll talk a little bit about it. I'll show you later also how it all comes together. But the shared metadata layer tells the query process where are the nodes that host the relevant data. Think about it like an index over the data, so that the query would be routed just to the nodes with relevant data. We could have thousands of nodes. We don't want to hammer all the nodes with all the queries. So the queries would be routed only to the node that has data that needs to be evaluated to satisfy the query. And each one of those nodes gets the query, and EdgeLake is running there. So they know to accept the query, and they know to process the query locally on a local database, which, by the way, can be any database of your choice. And then from there, each node returns a result to the node that orchestrates that, which is the node that I'm talking to. All those results are aggregated and returned as a unified result to the application. So this query that I was running here returns the same result that you would get if you were to move all your data from the edge to the cloud. So you could think about this process in this way. Today, what companies are doing, they are taking all their edge data and moving it to the cloud. And the reason is that's where the queries are running, and that is the place where we've built our software solution. Here, under this model, the data remains in place. The queries go to where the data is, at the edge, and being processed locally at the edge. And only results are coming back on the wire. And this is much more efficient, and obviously it saves all the cloud costs. And it's all plug and play. So this morning I gave a talk about how this platform could enable federated learning. So I won't go into all these details, and we showed a demo how you could train models and only aggregate. You could aggregate models that were built on different edge nodes. But if we think about the state of AI today in the context of the edge, we could say that today there is no data platform at the edge that can efficiently serve AI workloads. You've got to centralize everything. You've got to bring everything to the cloud or to some centralized database. AI models lack access to local data. You have to build it and tailor it yourself. Edge data is fragmented, so the data on one node could be very different than the data on another node, which may require a lot of engineering work and effort to do it. And if you have 2 nodes or 3 nodes or 4 nodes, that's maybe doable. If you have hundreds and thousands of nodes, this is not practical anymore. Federated learning today is blocked by the inability to access distributed data. We solve this thing with this approach, and this platform is very, very, I would say, intriguing in the context of agentic AI. We've got multiple companies that look at agentic AI. Agentic AI means that you've got smaller agents, let's say on the industrial plant or in oil rigs, that needs to do decisions and shut valves and alert and whatever is needed. And all of that needs to be based on data. But it's really hard to do that when you've got data that is distributed in many places. This platform brings a setup where on every node, in the same way that I queried and I got the result from 10 nodes and I was able to view it in my browser, an agent that needs to make a decision can see all the data that all the nodes around him maintain as if it is local data. And it makes it really easy for it to query the data and make decisions. So from here, let me show you a little bit of the what EdgeLake looks like. All right. So if you look at EdgeLake, it's basically a collection of services, of software processes that bring the services. You could think about the cloud. One of the reasons that the cloud is very attractive, it's got all those services there, so you don't need to deploy databases. You don't need to deal with security. It's all pre-built there. When you go to the edge, none of that exists. So it's really your problem, your issue. You have to figure out which services to bring there. You need to bring an MQTT broker, a database. You need to bring all of those services to many edge nodes and configure it there, which creates a lot of issues. Those are really long processes that could have a lot of issues if you have a lot of nodes. So EdgeLake brings all those services to the nodes. It uses the blockchain as a metadata layer. So we talked before about synchronizing all the nodes. The blockchain here serves in the role of making all those nodes operate as a single unified machine. It's completely hidden and transparent. You don't see the blockchains. You've got APIs if you want to interact with it. And I could show you a few examples. It's a transparent layer, but it contains all the metadata. So the data remains at the edge. The blockchain maintains and serves the metadata. If you don't want to use the blockchain, there is a way to run a blockchain emulator. We call it a master node, where the metadata is hosted at the node. So you've got also another option. If you don't like the blockchain option, you could maintain it yourself, the metadata layer. So the way, if we look at the node, the way it works is you've got all those things that generate data, and the first thing to do is to capture the data and bring it to the node. So EdgeLake has a series of native APIs, but you could also always use third-party platforms to capture the data. So for example, we've got OPC UA. So if you want to use OPC UA to bring data in, there is a native one, but you could use EdgeX, Node-RED, Telegraph, whatever. There are commercial products there. It doesn't matter. EdgeLake really starts to operate when data reaches a node. It needs to be in JSON format, and all the rest is automated. So when it goes in, it has some processes, and I'll show you what are the processes or who determines, how it is determined, which processes would act on the data, but at the end result, the data is hosted in a local database that could be your choice. It's a configurable platform. We, by default, use Postgres if the node is large and we expect a lot of data, and we use SQLite if we deploy it on a switch or a place where Postgres doesn't make sense. So not only it's hosted in a local, on a local database, the data is also available once it's reaches a node, it's available through a virtual layer that we've seen. You'll issue a query to a different node. If the other node needs the data which is captured on this node, this would be part of the result set. And then there are services that would allow you to push the data or service the data to different applications. So you could push the data natively to Kafka, you could use REST, you could issue SQL requests. What I was demonstrating before, I issued the SQL request and send it over REST to the node, and from there, I got the result. So what we've seen before is a single node with all the services that are built in. The interesting question is, what happened when we have a lot of nodes? So we saw that it's working, but what happens here is there is a virtual layer that is created that spans across all the nodes, such that if you issue a query to any node in the network, the APIs that get the query are above the virtual layer. So the query would be satisfied from all the nodes underneath, regardless where the data is. So I'll show you one step deeper what's going on under the hoods. So the first step, you deploy your nodes. It could be on the industrial plant. It could be in the city, wherever you want, and you deploy EdgeLake there. There is the shared metadata layer that organizes all the metadata, which could be hosted on a blockchain or on what we call a master node. It's like a blockchain emulator. And the metadata is organized in policies. Those policies could be whatever you want. So there are things that EdgeLake would push into the metadata layer that it needs, but it's a very useful platform. We are seeing companies that are leveraging the metadata layer, for example, to configure their processes, which are not necessarily EdgeLake. So we could talk about that also, but it's a shared layer. All the metadata layer is there and shared among all the nodes. And that's what makes all the nodes operate as a single machine in the way that I'll show you here. The next thing is you capture the data, and the data can come from cameras, sensors. All you need to do is bring the data to a node in the network. And again, there are native connectors. You could use third-party connectors to do that. And that's it. So if a user wants to query, he would take the query. A user or an application would take the query and push the query to a node in the network. It doesn't matter which one. That's what I've done in the demo, right? The node that was listed at the top. I just handed this node the query. And this node now looks at the query, and it looks at the shared metadata layer, not to bring the data, just to make it clear, the data is on place. It hasn't been moved. But the shared metadata layer has the metadata, and for that particular process, it would tell the query where the nodes with the relevant data are. So this node that got the query knows which are the nodes that host relevant data, and now it would work like MapReduce, if you will. So the query would be shipped to those nodes, and each one of those nodes would process the query locally. And there is a lot of effort to move all the processing to the edge, to do it on those edge nodes. And only result back are going into the node that orchestrates it, the node that I'm using as a gateway. And from there, the result set, the complete result set, is being serviced to the application. So what's interesting to see on this model, so I'm on purpose showing here a different query, and you could see it touches different nodes. There is very little contention in this model. So my background, I was a founder of a database company, and in database, the problem is that one of the main problems is the huge contention. All the data is in one place, and you've got a lot of processes that are after the data. In this model, the nodes are distributed, so the level of contention is much lower. Another thing which is really interesting here, the scalability, because if you think about this model, in the example that I'm showing here, an application or a query is being satisfied by 3 nodes, but let's say that the performance is not good enough. All you need to do is add another node, increase the distribution of the data. So instead of 3 nodes, let's say it will go to 6 nodes. So now you increase the degree of parallelism. You have more CPU to satisfy your queries. The amount of data on each node is lower, and you could take this model and adjust it to the performance that you need, and it's really easy to do. You just add another node, and there is a lot of effort about deployment, making it easy. So I don't know how many of you know about the platform called Open Horizon of IBM. You could download EdgeLake now as part of this platform, and it's a platform to orchestrate deployments at the edge. So not only the query of the data could be done in a very simple way, but also the deployment of the software. And then, like I said, the cloud still has a role, but for sure, much less data. But if you want to move data to the cloud, it becomes really easy. It becomes like a query from the edge. We've got connectors to Kafka. You could use REST. You could bring whatever transport process that you want and integrate here. So you could think about it as a layer before the cloud. I mean, some people told me it's like a virtual cloud. That's why I liked it and put it here. But for sure, your starting point at the edge doesn't have to be streams of bits. It could be a virtual layer that would get or satisfy a core of your queries rather than do it in the cloud. And obviously, huge cost savings. So let me show you how simple it is to use it and why users that implement it can do it in a couple of hours, and they could have a really complex setup deployed and running. So the first thing to do is to download or deploy on the node EdgeLake core. And you could use Docker, Kubernetes, like I said, Open Horizon. There are a bunch of platforms that could do that. And the next thing that you would do, you would enable the services that you want to be available on the node. So think about it. You bring a node, you might want it to host data. You might want it to ship data to other places. So you do that by enabling services. All you need to do is list the services that you want to be available there with some configuration. I mean, this is the IP and port I want to use, and so on. So those are optional. You could configure different nodes in different ways, and then that would give you the functionality, the profile of the node. By the way that we do it in a large deployment, all those configurations, which services we want to enable, we publish it also on the blockchain, on the shared metadata layer. And so when we bring up a node, we could say use configuration number 7, and it would know which services to enable on the node. Then there is another layer which is automated. You don't need to do anything about it. You'll just get it, which is an hardware abstraction layer. And what it does, the role of this layer is to make all the hardware components look the same from the outside. So regardless if you're running it on a small switch or a large server, it will always look to you, the node would look to you the same from the outside. And then on top of it, you've got the CLI and the API. Every node has a command line interface. You could just, everything that I've done in the example with the city of Sabetha, you could run it locally on the node. You don't need to push it via REST like the way that I've demonstrated it. And we already saw that those CLIs are running on top of the virtual layer. So on a CLI of a node, you could look at the status of a different node, or you could look at the status, all the nodes deployed in the US or in Kansas, or whatever your use case is. So the last thing that I'll show you, there is this basic deployment that you could, if you download the software and try it, it would talk about that. Basically what it would tell you to do is a demo network or a basic setup where we have 2 operator nodes. So operator nodes are nodes that host the data, keep it locally. So it will tell you to deploy it. Then you could use the blockchain or the master node. So if you use master node, you have to deploy another node that would serve as a master. It's the blockchain emulator, right? Now, and you could use our services to push data in. So we use it in testing. We could give you an MQTT broker, and you could just pull the data from there. Or you could push your own data using REST, using any one of the connectors that are there. You deploy what we call a query node. Again, it's an EdgeLake node that is configured to accept queries, and basically that's it. Now you could take your application, push a query to your edge node, to the node that you want to use as a query node. This node would look at the metadata layer to understand where the data is. That would be transparent, and it would give you the results from the data set, regardless of where the data is. So the data could be distributed all over the world. You could talk to your local node and get the result. You'll see all the data from all over the world as if it is local on your laptop or local node. So that's it. Any questions? Yes, please.
I have maybe 3 questions. First question, let's imagine that our network suffering from partitioning. How it's possible to guarantee that data that we receive from SQL request, for example, will be consistent? Because we don't see like part of the network.
Yeah. So the question, I was asked to repeat the questions because they're recording it. Yeah, so the first question was how do we know that it's consistent? I'm seeing a node, I'm running a query. How do you know that I'm not missing data on a different node that may have some other portion of the data that is needed to be part of the query? Okay, so the answer is that's one of the roles of the shared metadata layer. The shared metadata layer have a list. So if I'm a node, I'll take a step back and I'll show you how it works. If I'm a node that joined the network, I would register myself. It's all automated. I would register myself on the shared metadata layer. Then I'll start to get data. So I'll register myself as a node that hosts this type of data. So when queries, to your question, when queries show up, I see from the shared metadata layer who are the nodes that needs to participate. So if a node doesn't respond, I know that I'm missing data. And then there is also an answer to that, what do you do then? But I always know which are the nodes that host my data. I could show you, it's a really good question. If I go to here, one of the things that we do here. I don't know how much time we have, but I'll show you how that looks. So if I do get virtual tables here, you could see here a list of databases. For every database, there is a table. The same way I could ask for a given table, give me the columns and so on. That's what the applications see. But to your point, if I right here get data nodes, and I run this request, you could see the same answer. You could see here a list of databases. For every database table, for every table, it goes all the way to the nodes that host the data. So in every second, I would know exactly which are the nodes in the network and where is my data, such that when queries are coming, they are satisfied in a complete way. There is no way that you wouldn't be able to get a complete data set.
Let's make the situation more complex. Let's imagine that we have one or several malicious nodes or faulty nodes that are trying to change the vision of data in some way. Can we protect from this because maybe somebody trying to fool us?
Yeah, that's a great question. So if you deploy EdgeLake as it is, it's assumed that it's you own the node. It runs on your hardware, and so it's trusted at the end of the way. However, we're releasing a version that would work with non-trusted data. So it's not out there yet. We haven't talked about it. It's actually the first time that I mention it. Because if you think about this model, I could manage my data, But to your point, if somebody else would show up and offer, I want to manage somebody else's data, there is a question, how can I trust him? And we've got a solution for that, but it's not available yet.
Okay, so short question. I believe that it's mostly about how to manage complexity of data. But let's use that we can use 6L, RDMA, fancy technology. Can we make something like common technology faster? And could this approach be better anyway in the environment of new technologies? That could be faster enough to have manage all the data in the cloud, for example.
I'm not sure I understand the questions. If you deploy that, data remains, we don't care where you deploy it. You could deploy it on the cloud, you could deploy it at the edge. What we're showing here is you issue a query, you get the result back, you don't need to centralize the data. That's much more efficient than taking all the data to the cloud. Where did you deploy it? I mean, we're completely agnostic to that. It's
You have assumption that some coherence or something like not very fast connection, slow memory. Let's imagine that our memory really fast, and we have a lot of memory. We can place all our data into this fast memory. We can access this memory in fast way.
okay.
Can this approach would be better anyway?
Yeah, I think so. I mean, that's always the case. If you have a setup and you put better CPUs, more RAM, I mean, at the end of the day, on each node there is database and there is networking. If you could optimize that, then it would run better.
I like that.
Thank you. Yes, please.
The shared metadata layer, is that like a layer 1 or layer 2 on the blockchain?
We use layer 2 to save the cost. Okay? Yes, please.
So on the small side nodes, you could run on an embedded Linux like a Pocket Beagle 2, just if it's running embedded Linux, it will still run?
Yeah, it has a small memory footprint, so less than 500 megabytes, and we could even shrink it more. So we haven't had yet a setup where we weren't able to deploy it.
And on the security question, I couldn't quite hear all the questions, but is the transport now just a TLS, HTTPS? What's the transport of your queries?
So yeah, so this model is very secure. The blockchain is here, and again, it's a separate whole presentation, but at a high level, all the messages are signed, and when a node receives a request, let's say I'm a node and you're asking me, give me the data, I would first validate that you are who you claim you are. I would use your public key, which is also published on the blockchain. I would validate that, and then I would look at a policy that shows your permissions. And only if you have permissions, then I'll satisfy the request.
In case you opt out of Ethereum, you said there's a virtualized blockchain.
Yes.
That relies on a single relay server. Would someone be able to implement an alternative consensus scheme that may also be distributed but not reliant on blockchain?
For sure. We are experimenting in different things, and the answer is yes. Any other question? Yes, please.
I did only see Linux and Windows there. Is there opportunity for that to be run on a Mac node?
Yeah, yeah, for sure. Yeah, it would work. Yes.
Do you recommend high availability databases and replicating a database across nodes?
We have high availability options. Right now, it's only on the commercial version of AnyLog, but there is high availability. So either you implement it yourself or you use the commercial version. On the commercial version, by the way, if it's a small project, you're testing it, we're very happy to let you try it and use it. Yes, please.
What would the data format support for data producers?
On the northbound connectors? Yeah, so the question was, what are the data format on the northbound connector? So it could, usually we push the data in JSON also. But you have an option to change it. I mean, you saw on the demo that I showed, the query was, the query returned a table format. So you could define when you run a query. We don't have time to go into it, but you say format equal JSON or format equal table. And there is also a way to pull the data to HTML and add graphic on it, and it's all automated. Really cool stuff, but I don't have time now to show it to you. But it's very flexible, and if there is something that you need, it's also really easy to make changes. Yeah.
If we have lots of sensors and actuators that are running microcontrollers and they speak Wi-Fi, Bluetooth, LoRa, whatever it is, or even wired in, is there a recommended protocol that's lightweight, like MQTT versus a WebSocket versus HTTP?
Well, the answer is no, but what I can tell you, one of the services that you could enable on an EdgeLake node is to say, I want the node to look from the outside as an MQTT broker. So you could just publish the data to the node, like it is an MQTT broker. So you don't need anything else between the source.
That's easy to enable.
Very easy. It's just a service. You say, I want MQTT, or you could just send it via REST. Then I think that even if you don't enable anything, I think it would work. So. Any other question? Yeah.
The metadata, is that going back and forth as JSON as well, or is that IPFS?
It's JSON. I could show you how it looks like. Do we have time, or I need to? I gotta go to another room. Okay. So, yeah. So maybe. Yeah, we could. So let me say two things. First, if somebody is interested, we've got a great team. We are very interested with projects. We'll help open source projects and even commercial projects that wants to leverage EdgeLake. So feel free to reach out to us. If somebody wants, I'll give you my card with all the contact information. There is a pager here that I brought. If somebody wants a written paper, I'll be happy to hand it. And yeah, thank you very much. Thanks a lot.